Thank you. Good morning. So I'm James Kretchmar. I'm from Akamai Technologies, and I'll be speaking about the state of the net, trends that we see on the internet, both today, and what it means for the future. Now, we have a very unique view onto the internet and its trends by virtue of what we do. So let me give a brief introduction of Akamai so you can understand what we see and why. So if you haven't heard of Akamai before, you're about to learn one of the coolest secrets on the internet, which is that a lot of the content that you receive comes from our servers for the big sites you're used to using. So we are the global leader in CDN services. CDN is Content Delivery Network. And so if you're a big content provider online, if you have a big e-commerce site or you're delivering online streaming video, it's very hard to give a good experience to end users all over the world. The internet's pretty chaotic, and so you need special technology to make that happen. And that's what we do. We have on our platform all 60 top global e-commerce sites. We have the top 30 media and entertainment companies, for example. So when you're buying things online, when you're downloading music, watching streaming video, a lot of the time you're getting that content from one of our servers very close to where you are. Other types of customers on the platform, we have the top 10 US banks, automobile manufacturers, and in the end, 1 out of 3 of the Global 500. So this is the first way we get a unique insight into the internet and what's happening, just by virtue of the fact that we have so many of the popular sites and so many of the end users that are coming to visit them. Now, in order to deliver that experience, that actually ends up being something like 30 terabits per second in terms of traffic that we deliver out to the end users. I'm an engineer, but 30 terabits per second, that's a little hard to think about how much is 30 terabits per second. So another way to look at it is that it's 40 million hits per second. So if you think about that, in 1 second, we get 40 million requests from end users around the world to the platform, and then in the next second, another 40 million requests, 40 million requests, 40 million requests. So it's a lot, and it's hard to make that work right. The way that we do that and give such a good, reliable experience is via our very highly distributed platform. So we've built the platform to have servers in 128 different countries, and we're in over 1,600 different end-user networks. That's really the trick to really good content delivery on the internet. If you at home on your ISP are getting content from a server that's in your same ISP, you'll get a good quality delivery. If you have to go out across the internet, that's where you start to have a lot of performance problems and difficulties. Now, this is another way that we get a lot of visibility into what's happening online. Just the fact that we have servers in so many different places all around the world, we really get good insight into the trends on the internet. Now, before I dive into the data of the state of the internet, let me tell you that all of this information is available online. We publish a quarterly State of the Internet report that you can find at stateoftheinternet.com. We actually have a connectivity report and then also a security report. And in fact, the Q4 2016 security report was released just yesterday. So if you visit online, you can get access to the latest information on the security threat landscape. We have both the physical PDFs of the reports available online. There's also interactive tools. You can work with the data, as well as a mobile application if you search for Akamai State of the Internet on your App Store. But let's dig into the data, and I'm going to bring the data up into a number of key trends that we're tracking on top of this data. The first trend I'm going to talk about is mobile and performance and what's happening in that part of the internet. Next will be trends in online video consumption and the technological changes that it's driving on the internet. Third will be security, and a lot of that data will come from that report that was just released yesterday. Fourth will be trends in enterprise networking, and finally, fifth, trends in Internet of Things. Okay? So let's dig right in. First, mobile. I'm going to tell you something a little bit crazy. The web is getting slower. It really is. The web is getting slower. And that seems very counterintuitive and paradoxical because All the technology is getting faster. Right? The networks are faster, the devices are faster, servers are faster. How could the web be getting slower? The reality is that the end user experience of websites is slowing down. This is data over several successive years, and at the bottom line, you can see the average amount of time it took to load pages for the end user. And it went from 7 seconds to 10 to 11, more than 11. It's taking longer to actually use the web. Now, why is that? If everything else is getting faster, why is the web getting slower? A number of reasons. First, the pages are heavier. It's much richer content. They're just bigger. There's more data. So it takes longer to transmit that data and get it to the end user browser. So that slows things down. It's also not just more data, but lots more objects, lots more things on the page to get across. There's a lot more JavaScript. You know, if you remember the web in 1999, it was kind of static pages, right? You would get a page and it was very static, except maybe if there was a blink tag, one of the worst inventions ever, right? You know, now we have rich, interactive, dynamic pages, and that's driven by code, by JavaScript. And that's extra data that has to be transmitted. And it also means the device has to think about it and process it, whether it's a desktop or a mobile device. So that slows things down. Then there's images. You know, old web pages, there were some images in different places. Now, basically, the whole site is images. And not only are there more images, but they're much higher resolution images. We have retina displays, and we want to take advantage of that. So higher resolution images means more data, more stuff to transmit, slower experience. CSS, that's another type of code. Third-party content. You know, if you think you're getting all that content back when you visit a web page from one server, nope, you're getting it from different services all combined together. So you might be getting weather information from one service and a map to the store from another. Maybe there's ad tracking or analytics beacons that you don't even see, and those all come together to affect the final page performance. But while all of that is important, the largest factor in why the web is slowing down is this. This is the growth in time of mobile voice traffic versus mobile data traffic. Mobile voice traffic is in blue, and you can see if you look real close, it's growing, but it's hard to see. But mobile data traffic is exploding. And this data is from about 2011 until Q3 2016. It's just exponential growth, right? And there's no end in sight. Now, mobile devices and mobile networks have very different characteristics than land devices, than your home computer on a fixed network. And it's not just that the network's a little slower, and so you get content a little slower because the network's a little slower. The technology is fundamentally different, and the way that it's interacting with the web protocols that we made 15 years ago is especially problematic. To give a quick view as to why that is, if you're not familiar with this, it's a waterfall chart. It shows what happens behind the scenes when you download a web page. It's not actually that you make one request and get back all the data. You have to make lots of requests. The first thing you request is a skeleton page that tells you everything else you need to do. That instructs you to then go make requests for each individual picture on the page. So in the top left here is the first request for the base HTML. And then you can see after that, we can start making additional requests for all the other objects. The problem is, a real web page looks like that on the right. That is hundreds and hundreds of objects that have to be requested. And that really slows down mobile networks in particular. They weren't built for this type of scenario. And I'll give a quick illustration of why. This is an illustration of requesting a web page at the protocol level. What you see above the red box there, that's the request for the page. That's just me asking to get the thing. Below the red box is the actual data coming back. Within the red box, those are headers. It's not the actual content. It's metadata about the content I'm going to get back. Things like how long it is, how long I should cache it for. Now, the original web protocol, HTTP 1.1, you have to return those headers with every single object. Every single picture on that page, you get another copy of this. It's usually all the same. There's not a lot of change in that data, and you can't compress it. So it's extremely inefficient, especially on a high latency network like a mobile network. So there's something we did kind of wrong here, right? We took two separate technologies. We had web technology, HTTP, and we had mobile technology, and they were developed independently, and we stuck them together, but doing that created a lot of inefficiencies. We didn't do it accounting for the two of them. But this is not acceptable anymore. Mobile web performance is so important that there's been changes to the protocols to account for this. So HTTP2, which was released just in the past couple of years, it's this change in HTTP for the first time in 15 years. And that's because we didn't really build it right. And now we're making a lot of changes on the internet to the base technologies to account for that. Now, a quick thing about why performance matters. It's not just nice to have. We know that performance directly impacts the end user experience, the end user behavior. So if a website is just a few seconds slower, end users are going to abandon it and do something else. And more than just behavior, it really affects the bottom line. This is a study we did with Walmart a few years ago. This is showing the blue bars here are the percentage of end users that received a page within a certain number of seconds. So all the way on the left, the blue bar is the percentage of end users that received the page in 0 to 1 seconds. To the right of that, 1 to 2 seconds, and then 2 to 3, and so on. So you can see a lot of users got the page in 1 to 2 to 3 to 4 seconds. Way to the right, there's a number of a lot of users where it took 11 seconds to download the page. Probably a lot of them were mobile users, but not all of them. But the really interesting thing here is the orange line, because that's the conversion rate. That's the percentage of users who made a purchase. And of course, the conversion rate drops off as the performance gets slower. But what's impressive to me is to see how quickly it falls. Between 0 to 1 seconds and 1 to 2 seconds, there's a dramatic fall in the conversion rate. People are much less likely to buy if you add just 1 or 2 seconds of delay. So performance is really critical. That's what's driving the entire industry to create new versions of the HTTP protocol for the first time in 15 years. So in terms of what to look for, there's more of this coming, right? HTTP2, quite honestly, was catch-up. It was catching up on the easiest things to do that we haven't done for the last 15 years. There's work going on now in the standards bodies for next-generation versions of HTTP and other ways to deliver content effectively to devices, including mobile devices. So that's one trend. Let's switch gears to video, online video consumption. We all know that we're consuming video online more and more. We have higher expectations for it. We expect to be able to watch in high definition, but let's put some data behind it. This is the growth in peak traffic on our platform from 2000 until the end of last year. Last year, the peak was 46 terabits per second. It's a lot. That's really a lot of traffic. But you can see there's exponential growth here. So while we've done a lot with that highly distributed platform to manage serving that level of traffic at high quality, we have to be very concerned with where it's going to go, right? How is this going to continue to scale? And do we need to evaluate new technologies to support the video growth for tomorrow? So we can model this out a few different ways. Exponential growth, you tend to think, all right, well, it's hard to maintain exponential growth for a long period of time, so it'll probably level out. The problem is, we think the exponential growth here might be the minimum. So if you follow an exponential growth model, by 2020, we might be talking about peak traffic of something like 340 terabits per second. That's sort of the modest way to start out. Let's look at another way to model this. Cisco has something saying that by 2020, 1 million minutes of online video will be consumed every second. That's a model that they have. Well, if we do the math on that one and work out the number of viewers and assume a 10 megabit per second stream for each one, that would get us to 600 terabits per second for a big online streaming event. But it doesn't end there. There's another model that says, from TDG Research, that by 2020, more people will be watching video online than on TV. OK, so if we think 700 million users, 10 megabits per second, that could be 7,000 terabits per second. Now we're talking orders and orders of magnitude more traffic than we're dealing with today. So this is the landscape. There's actually one more model I'll show you. Our CEO, Tom Layton, he's a mathematician, and so he often comes up with very interesting and complicated and fancy modeling formulas. But in this case, he has a very simple one. Imagine by 2020, for some big primetime viewing event, you've got 2.5 billion viewers, right? Which is understandable. And they're each watching at a 10 megabit stream. Well, that would land us at 25,000 terabits per second, right? So there's a wave of video traffic coming. And this is just talking about a 10 megabit per second stream, right? This is sort of a high-end, high definition. Never mind about virtual reality, augmented reality, and everything else, which is even more complicated. So The result here is that there is increased interest in the industry in some new technologies for making online video work. One of those is UDP delivery. Now, I say new technology, but in some sense, it's an old technology. We used to deliver video online via UDP traffic. This means just send the packets and don't worry about if they got there or not. Then we shifted to TCP, and now we kind of want the best of both worlds, so there's hybrid solutions that are being evaluated. Another one is multicast. If you haven't heard of multicast, let me explain quickly what it is. Today, if you're in an office building, say, and you and 100 of your colleagues are watching the same video, you get 100 copies of that data sent into the office building. So it's really wasteful. Multicast is a technology where one copy can be sent, and anyone who wants to watch it just taps into that one copy. Now, this is another technology which actually is very old. It's been kicking around for over 20 years. I remember we experimented with it in college, but now it's coming back in a serious way. People are trying to figure out how do we make multicast work for real. There's other technologies that will be key here, intelligent pre-positioning. If you can get the content where it needs to be ahead of time by guessing what the user is going to watch, that can help the situation. And peer-assisted delivery. Maybe you don't have to get as many things centrally. You can get them from other nodes that are close to you. These are all technologies that may be in the near future for online video delivery. The other thing that's going to come with them is the need to make it more highly distributed. I mean, today, what we've built is a network that goes out to the very edge of the internet, close to the end users. We have some technology which is in the clients as well, in the software, in the computer. But where we need to end up is even further out, in the home, for example, in order to make intelligent decisions about which of those technologies to use when. That's going to be fundamental. So, that's the trend in online video. Let's switch gears and talk about security. And this one, we just released the report yesterday on Q4 2016 State of the Internet. Now, anecdotally, I think you all know what's going on in security because you can open a newspaper and see it. Just everything's getting attacked all of the time. Every week you can read about some new one. It's in the mainstream media. It's not some esoteric nerd thing anymore. But let's try to put some data behind it to understand what we're talking about. This is showing growth in the sort of largest attack that we see against customers on our platform over time, the peak attack. The largest attack in 2016 was 620 gigabits per second. Now, this growth, you can see, it sort of looks like the media growth in that it might be exponential here, but it's a little choppy. It's certainly not smooth. You can see 2014 to 15, the largest attack in 2015 was actually a little smaller than the largest attack in 2014, but then 2016, all of a sudden, it doubled, and we made up for it. So what's going on here? That largest attack in 2016, I think you saw that one in the press. That was the Mirai botnet attack. And it's sort of the first real Internet of Things attack, right? This was compromised DVRs and video cameras, video cameras that were used to attack a site that was on our platform. So, we see there's these evolutions in the security landscape where all of a sudden a new thing happens. People had predicted an Internet of Things attack would happen. We just don't know when. Well, the answer was 2016. What's scary about it is that that Internet of Things attack was only using a very small percentage of the things on the internet. So while it's the largest we've seen so far, we know it's not the largest that's going to occur. We just don't know how big and when. Getting past that a little bit, we know that attacks are growing over size. We also know they're getting more frequent. This is a scatter plot. There's just a dot for every time someone was attacked. Each band here is a different quarter. So attacks are the normal course of business now. There was a time, I remember, when an attack on a customer on our platform was an interesting event. It happened once a month. And so we kind of, someone's being attacked. Let's go take a look. That's exciting. But now it's up to many attacks per day. This is just the landscape. This is the new normal. So you have to be protected and able to withstand that. I'll skip this in the interest of time. There is one piece of good news here, a silver lining, which is that we see some of the older attacks are getting a little bit less effective. There's cleanup going on the internet. This is talking about the number of clients that were employed in certain types of attacks. NTP, which you see in the second column here, that used to be the largest in 2014. That was a very popular mode of reflection attack for taking down sites. The numbers come down. Of course, something else has replaced it, SSDP, but NTP is getting cleaned up. The server admins are patching their servers. It's getting a little commoditized because it's competitive to get access to those bot networks. So things are getting a little better in some areas. This is the effectiveness, the average NTP reflection bandwidth over time, and you can see while it was a very popular attack in 2014, now it's not as effective anymore. So I guess there's a little bit of a hopeful story there. One thing that's very clear, I want to just make sure that everyone's on the same page about, is that a distributed attack like these, you have to have a distributed defense. You're going to see, as part of the coming trends, a lot of talk about cloud security. And it's tempting to think cloud there means the same thing as cloud in other circumstances, where maybe cloud means it's convenient because I don't have my own server, someone's running it for me. But the key thing here is it's cloud because it needs to be very highly distributed. For those distributed attacks, you need a distributed defense mechanism. But the other thing that I want to talk about with respect to security is the other thing that's going on that's not so obvious. You might remember 2 years ago, 2014, there was the Heartbleed attack. It actually has sort of fallen out of the things that we talk about day to day, but the effects are ongoing, and so it's really important. Heartbleed, if you don't remember, was a flaw in the OpenSSL. It was this crypto implementation that a lot of web servers use, and it made it possible to extract the private certificates, the secrets that are used to make sure a site can't be impersonated. If you get the secret out of a site, say it's a bank, then you could stand up your own server and pretend to be that bank and convince end users to come and perform transactions with you. So Heartbleed was a big deal because of this vulnerability. Everyone patched, and then they rotated or changed out their secrets. But then, it's not enough to just issue a new secret. The way that system works, you have to issue a certificate revocation, because that secret was valid for maybe up to a year, and you have to publish a thing saying that old one is no good anymore, you can't use that. But the system was not designed to handle tens or hundreds of thousands of sites having revoked certificates all at once. And browsers and end-user devices do not consistently implement this certificate revocation system. What this means is we built something wrong, right, as an industry. This technology has a real problem to it, and even though we got past Heartbleed, there's a lot of work going on now in standards bodies to figure out what the next generation version of security is going to look like on the internet. There's a lot of discussion. Maybe it's much shorter certificate rotation lifetimes. There's things like certificate transparency. There's a lot of ideas, but it's changing right now. And this is another thing like HTTP2 where we lived with it for 15, 20 years, but right now you're in the middle of a time when it's changing. Let me touch quickly on enterprise networking. The classic enterprise network, you have a data center, a corporate data center, and branches that are connecting to it for everything that they need to do. It's their only connection. We're seeing, of course, more and more often that there's a desire to access the cloud for what were previously enterprise applications in a data center, CRM software, or whatever it might be. So we have the cloud. Branches want to access it, but in the traditional model, the branch only has access to it through the corporate data center. So this is obviously a little inefficient and taking a much longer path than is necessary, and this just doesn't seem like the right model. So more and more often, the branch is connecting directly to the internet. It's cheaper. It's one thing that's nice. In some ways, the performance can be better. But this introduces new challenges for the corporate security officer, because now none of that traffic is being monitored, controlled, or protected by the corporate security infrastructure. So it's very easy for devices in that branch to get a virus or some type of malware from the public internet. And then, by the way, that branch has access back into the corporate infrastructure, so it's twice as bad. So that's introducing a challenge, and then more and more often we also see the desire is actually to have users not at the branch that are accessing the enterprise applications as well. Maybe that's your mobile workforce, maybe that's contractors that are out at remote sites that need to access the enterprise applications. So there's an effect here where the enterprise network is effectively being turned inside out. This desire to use the cloud is turning a lot of things around. I would expect to see over the next few years a lot of technologies come into play to help resolve this situation. And finally, the last trend that I'll talk about today is Internet of Things. Now, every Internet of Things talk that I go to falls into one of two categories. It's usually either someone telling me about all the amazing devices that are going to be connected, my refrigerator and my shoes and everything else, and how that's going to change my life. Or it's about the security vulnerabilities. What's going to happen when my shoes get hacked, or what's going to happen when the electric grid gets hacked, which I guess is more scary than my shoes, maybe depending. But actually, those are sort of the fun things to think about and talk about, but there's actually much more fundamental problems that we need to consider. So remember, I said the internet is chaotic, right? It's this just all stuff connected to other stuff, and the protocols are all best effort. It's this big, big chaos that spans the whole world. And your car is in one place, or your connected device, and the server it needs to talk to is somewhere else. Right? And getting across all of that is difficult. And it's even more difficult now that we'd be talking about something like tens of thousands or hundreds of thousands or millions of devices that need to communicate. So we've been working, for example, with automobile manufacturers. They want to do over-the-air updates of the firmware on their cars. And they're doing that today. Many cars with major automobile manufacturers get their car firmware updated over the air. It's cheaper for them, but it also gets the updates out quicker. And if that was a really critical life-saving change, you want that deployed to your fleet as quickly as possible. But the other thing that I would expect to see is a lot more around what happens in the other direction. All of these Internet of Things devices, they're trying to send in telemetry data to do what they want to do. And that has a lot of challenges, both in terms of just the networking of getting all that stuff across the internet. But then how do you can't update a database with each of these entries as soon as it comes in. That just doesn't scale. And some decisions need to be made locally. So look for technologies that are going to help with the Internet of Things from a connectivity point of view. So these are the key trends that we're tracking. But the big thing I want to leave you with is this. You saw from each of the areas I talked about, there's a change going on now that is bigger than since the internet was created. Right? If it seems like, hey, we've got this internet thing and it's mature now and it's just going to go on some steady growth, that's not the case at all. There's huge change in the underlying technologies of the internet, and those are going to drive the technologies of tomorrow and for the next 5 and 10 years. Thank you.